Hey everybody, we're going to go over section 1 in chapter 6 today. We're talking about the law of sines. This might be a little bit of a review for you for some of it and new for part of it as well. Let's jump in. So today in this lesson, we're going to use the law of sines to solve oblique triangles and figure out the areas of oblique triangles as well. So what's an oblique triangle? It's a triangle that has no right angles. Okay, so that's pretty easy. State the law of sines. So we know if A, B, and C is a triangle with sides A, B, and C, then we know this. Side A divided by sine of angle A equals side B over sine of angle B is also equal to side C over sine of angle C. So these are proportional. And remember, when we label these triangles, if we label these angles with capital letters, their opposite sides are lowercase. So angle A is opposite of side A, angle B is opposite of side B, angle C is opposite of side C. So let's see. To solve an oblique triangle, you need to know the measure of at least one side in any two other parts of the triangle. Describe the two cases that can be solved using the law of sines. So we have a couple of different ones. So when we're given either a triangle where we have two angles and a non-included side, that's called the angle side triangle. When we have a triangle where we have two given angles and an included side, that's the angle side angle triangle. And the last option that we have to solve using law of sines is a triangle where we're given two sides and a non-included angle. That's called the side angle. So let's go on to the next one. For example 1, for the triangle shown at the right, and we're going to fill this in. If angle A is 31.6 degrees and angle C is 42.9 degrees and side A is 10.4 meters, find side C. Well, I know in order for the law of sines to work, I forgot to fill this in before. Basically, in order for the law of sines to work, as long as you have one side and its opposite angle given, whatever you have left over, the law of sines are going to still work, okay? So we see here we've got angle A and its opposite side. So that tells me I can use the law of sines here. What we're looking for is side C, which is opposite of angle C. So this is side C right here. And again, we're given its opposite angle, so we're in good shape. So let's go ahead and set up using law of sines. So we know that in opposite sides, so let's use side A, 10.4 over the sine of its opposite angle equals a side, which we're looking for C, over its sine of its opposite angle. Now, to solve this, we're going to cross multiply. So we get C times the sine of 31.6 degrees and 10.4 times the sine of 42.9. Now to get C by itself, I'm going to divide both sides by sine of 31.6 degrees. If I plug that into my calculator, making sure that my mode is in degrees, we get 13.5 meters. Okay, so let's talk about the ambiguous case now. If two sides and one opposite angle of an oblique triangle are given, there are three possible situations that occur, which are: 1 is that no such triangle can occur. 2, one such triangle can occur. Or 3, two distinct, meaning different, triangles can satisfy the conditions. Okay, so let's talk about what that means. So let's look at this. So this chart here is from your book on page 406. And I want you to take a minute and just kind of either look at it, reference it, take a picture of it, put it in your notes, or you can turn to that book page in your book and write this down. But this is how we can know how many options there are for us. Keep in mind, one new thing that we're bringing in is this idea of that there's a height of a triangle. And remember, the height is the perpendicular side that goes through a vertex to a base, okay? So if an angle is acute, which we have these 4 cases, right? And we know side A is smaller than what the height would be, this is no possible triangles. If side A is equal to the height, there's 1 possible triangle. If side A is greater than one of the other sides of the triangle in between the height and that angle, we know there's 1 angle possible. Now, if the height is in between either, it's less than both options for side A and our side B, there's going to be 2. And we'll talk about what that means in just a minute. And then if we've got an obtuse angle, there's 2 options here. So if it's an obtuse angle, sometimes the sides don't always line up. If side A is less than side B, it's not going to work. And if A is obtuse and side A is greater than angle B or side B, then there's 1 option. Note that the height is the B side times sine of angle A, whatever your given angle is. Okay, so that's one way we can calculate that. So let's go ahead and bring this up here and start looking at this. So for triangle, we're going to draw this out. Let's draw it, and we may or not be drawing it to scale. Here's angle A, B, and C. If angle A is 25 degrees and side B is 54 feet and side A is 26, how many solutions are possible? Well, we're going to use that same chart here, and I'm going to draw in the height. So this would be the height. Well, remember, we know that the height is side B times the sine of the angle. And in this case, our angle is 25. And the B side is 54. If I plug that into my calculator, I get 22.82. Let's compare that to sides A and B. So in this case, H is 22, A is 26, and B is 54. So that tells me that the side H is less than side A, is less than side B, which if I look at my chart, H is less than A is less than B, tells me there's 2 options here. So I know that there are 2 possible. All right, let's go ahead and use this information and solve here. For the triangle at the right, angle A is 110 degrees, side C is 16, and side A is 25. Let's find the length of side B. So we're going to go ahead and do this. And we know here we can use the law of sines because we have an angle and its opposite side. So we're going to set this up that we've got 25 over the sine of its opposite angle equals actually we're going to have to find angle C first because the only other piece of information we're given. So we're going to find angle C first. We're going to cross multiply so we get 16 times the sine of 110 equals 25 times the sine of C. I'm going to divide both sides by 25. Now remember, if sine C equals 16 sine 110 all over 25, I'm going to have to take the inverse sine on both sides. So we get angle C equals the inverse sine of 16 times the sine of 110 all over 25. So put that in your calculator, but make sure it's in degrees. And we get angle C is approximately, if I round it, it's 37 degrees. Now that I know that 37 degrees, we can easily find angle B if I take 180 and I subtract it from the sum, and we get 33 degrees. Now, if I want to find side B, now we can set up the law of sines again. So we can say the sine of 33 all over side B equals, and we can use either of these sides. We will say sine of 110 all over 25. And if I multiply, I get 25 times the sine of 33 equals B times the sine of 110. To get B by itself, we're going to divide both sides by the sine of 110. And we end up with B equals about 14.5 centimeters. Okay. And then lastly, to find the area of an oblique triangle, and the area of any triangle is 1/2 the product of the two lengths of the sides times the sine of the included angle. That is, the area is 1/2 of the two sides times its included angle, which is also, let's say we could write the other two sides times its included angle, or the last two sides times its included angle. Okay, so let's go ahead and finish off this example and then we'll be done. So find the area of a triangle having two sides of lengths 30 feet and 48 feet, included angle of 40. So if I were to draw this, this is our angle, included angle, this is 30 feet, and here's 48 feet. To find the area, I know we're going to have 1/2 of the two sides times its included angle. Plug that straight into your calculator, make sure your moto's in degrees, and we get 462.8 feet squared. All right, go ahead and submit this to notes for today and come back, and I'll see you in a minute.